So, hello everyone, good afternoon. So, I think I'm visible and audible to all. And in this session, we are going to discuss the chemical kinetics as a crash course. Okay. So, the topics that we are going to cover in today's session from chemical kinetics are the introductory part of the chemical kinetics and the rate law and rate constant, order and molecularity of a reaction, then zero first and pseudo first order reaction, factors affecting the rate of the reaction, and Arrhenius equation. So these are the topics that we are going to cover in today's session, and then we are going to discuss some previous year's questions of JEE and NEET from the topics that we are going to discuss. Okay, coming to the first thing, the introduction. So what is chemical kinetics? It is a branch of physical chemistry which deals with the study of rate of the reaction, mechanism by which the reaction proceeds, and the factors affecting the rate of the reaction. Okay, the speed, basically the speed of the reaction it occurs, that will be studied under this chemical kinetics. Okay, coming to the rate. So how to find out the rate of a reaction? It is nothing but the rate of disappearance of A and the rate of appearance of B. So if I'm having A and B as reactant and P and Q as product, then the rate of disappearance of A and B, that will be equal to the rate of appearance of P and Q. Okay. So the change in the concentration of the reactant with respect to time is nothing but the rate. Okay. So since A and B, they are the reactants, the concentration of A and B will be decreasing. So we are representing it by using the sign minus. So it is minus dA by dt, and for B it is minus dB by dt. And the product is appearing, no, products are formed. So it is dP by dt and plus dQ by dt. And we have to put a negative sign for reactant and positive sign for product. And since we are having m1 moles of A and m2 moles of E, so that stoichiometric ratio has to go to the denominator. So it is 1 by m1 minus dA by dt, which is equal to minus 1 by m2 into minus dB by dt, and 1 by n1 dP by dt, and 1 by n2 dQ by dt. So this is how we have to write the rate, and all the rate will be equal. So you can see the equal to symbol here. So all the rate of the reaction will be equal, and it is always positive. Rate of the reaction is always positive. Negative sign represents the decrease in the concentration of the reactant. Coming to the unit, it is mole per liter per time in terms of concentration. And if you want to represent the time in seconds, then go for this unit. And if you are representing it in a minute, do it like this. And for hour, it is mole per liter per hour. Okay. So this is about the rate. Now coming to the rate law and rate constant. What is rate law? The experimental expression of rate of reaction in terms of concentration of the reactant is known as rate law. Suppose I'm having AA plus BB giving product. The rate law for this reaction is rate is directly proportional to concentration of the reactant A raised to X and concentration of B raised to Y. So these are the exponents, the values of exponents X and Y. They are found experimentally. It may be same or may not be same with A and B. Okay, stoichiometric coefficients are A and B. So X and Y can be equal to A and B, or it cannot be equal to A and B. Okay. Now, if you remove this proportionality symbol, we have to insert one constant, right? And that is K here. And that K is called as rate constant. Proportionality constant K is known as rate constant. And rate constant does not depend on the concentration of the reactant, but it depends on the temperature and catalyst, which is very, very important. Rate constant does not depend on the concentration, but it depends on the temperature and catalyst. Now, how to find out the unit of rate constant? So you can use this general formula. It is mole by liter power 1 minus n time inverse. And this n denotes the order of the reaction. For 0 order, n value will be equal to 0. So substitute 0 in place of n. So mole by liter 1 minus 0. So it is mole per liter time inverse. And if you substitute 1 here, 1 minus 1 is 0. So the whole term to the power 0 becomes 1. So it is just time inverse. If you put n as 2, it will be minus 1, right? So mole inverse, liter, time inverse will be the unit of rate constant for second order reaction. Like this, we can substitute 3, 4, 5, and we can get the corresponding unit for rate constant. Okay. And if for the gaseous reaction, we cannot use mole per liter, right? Mole by liter. It is atmospheric into time. So instead of mole by liter, you use ATM power 1 minus here. The other things remain same. Okay. So this is how we are calculating the unit of rate constant. Now coming to the order of reaction, sum of the powers of concentration terms present in rate law expression is called as order of the reaction. So here we have AA plus BB giving product. And if I want to write the rate equation for this, it is equal to K into A power X P power Y. So the order of the reaction with respect to A is X, and the order of the reaction with respect to Y is B, with respect to B is Y. Now the overall order will be X plus Y. It is always determined experimentally. It can be positive, it can be negative, it can be 0, or it can be fractional also. If X value is 1 and if Y value is also equal to 1, then 1 plus 1 will be 2. So order of the reaction will be 2. So like that, we have to just add up the powers and then calculate the order. Okay. But coming to the molecularity, molecularity is a theoretical quantity. It is not determined experimentally. It can be an integer only. It can be an integer only. It can be 1 or 2 or 3. It cannot be 0. It cannot be negative. It cannot be fractional. Okay. And in elementary reaction, molecularity is always equal to 0. For simple reactions are called as elementary reaction. So for those reactions, molecularity and order are same. But for complex reactions, which involves more than 2 steps, so the molecularity of each step of mechanism is defined separately. So you have to get the number of molecules that is reacting in each step, and then you have to get the molecularity. Okay. So maximum value of molecularity or order is only 3. It cannot exceed 3 because the chances of effective collision of more than 3 molecules is very, very rare. Okay. So this is about the molecularity of the reaction. Now coming to zero order, reactions in which rate of reaction remains independent of concentration are said to, independent of the reactant concentration are said to be zero order reaction. Okay, rate of the reaction, if they are independent of the concentration of the reactant, then they are called as zero order reaction. Okay, if I want to write the rate equation for this, rate will be equal to K into, let me take A as reactant, A to the power 0. Okay, this is the rate equation for zero order reaction. Some of the examples are given here. H2 plus Cl2 giving HCl, NH3 in presence of platinum catalyst and on heating produces nitrogen and hydrogen gas, and the dissociation of hydrogen iodide on gold surface. These are some of the examples of zero order, which are also very important. Coming to the integrated rate equation part of zero order, it is these two relations you have to study. This is the integrated rate equation, which is of formula y is equal to mx plus c. Mx plus c. Slope is minus k for zero order, and k is nothing but the rate constant, right? If I want to derive the relationship between rate constant and time for zero order, then use this relation. Both are very important. A naught means initial concentration of the reactant, and AT means concentration of the reactant after some time t. Okay. Then to find out the half-life period for zero order, it is A naught by 2K, which is again very important. T half is equal to initial concentration divided by 2K. Okay. Now, let us see the graph that denotes these two equations. We'll see the graph for this integrated equation and for half-life. So here is the graph. So minus k is the slope, right? So it is negative. Slope is negative, means it has to come from this. Top to bottom it has to come, right? The line should be like this. and A naught is the intercept C, and this is the intercept A naught, and here minus K is the slope. So for AT versus time. And for T half versus concentration, you see T half and concentration, they are directly proportional. For zero order reaction, half-life is dependent on the initial concentration. So if one increases, other one also increase. So we have a positive slope with 1 by 2k. The line is going from 0, okay, to the right side. Positive slope. Now coming to first order. Next, coming to first order, the reactions in which the rate of the reaction is directly proportional to the concentration of the reactant is called as first order reaction. So some of the examples are given. So the rate will be equal to K into A to the power 1. So this is first order. So nitrogen pentoxide, hydrogen peroxide and all radioactive decay reactions will fall under first order. Now here is the integrated rate equation, which is a formula again, y is equal to mx plus c. So again we'll get a straight line. Slope is again minus k, and this is the rate constant relation for first order, which is equal to 2.303 t into log of A naught by AT, which is a very, very, very important relation for all the numericals that we are going to discuss here in this lesson. Okay, and the half-life period, you see here it is 0.693 by K. It is independent of the concentration. So half-life is independent of the initial concentration of the reactant for first order. So these two things you have to keep in mind. Okay. Now let's see the graph for integrated rate equation and half-life. So here again minus K is the slope, but ln A naught is the intercept. So ln A naught is the intercept and minus K is the slope, and y-axis is the ln AT. And for half-life, since it is independent, half-life is independent of the concentration, it maintains a straight line. Okay, even though if you increase the concentration, half-life will remain same. Okay, so all the graphs, the formulas, those are very, very important. Okay, now let's go to the pseudo first order reaction. What is pseudo first order? Pseudo means false. It is not a first order reaction, but it is a first order reaction. A chemical reaction in which value of order of reaction is 1, but molecularity is more than 1 are known as pseudo first order reaction or pseudo unimolecular first order reaction. Examples are hydrolysis of ester in acidic medium and inversion of cane sugar. So here you see ester is reacting with water in presence of acid and it is producing acetic acid and ethanol. So how many reactants we have? A plus B, we have 2 reactants. But, and to write the rate of the reaction, it is equal to K into the concentration of both the reactant A and B. But water is present in excess. So the excess reagent concentration will be negligible. So we will not take that into account. So we are eliminating that and we are getting K dash into the concentration of ester. Actually, 2 reactants are involving, but only one of the reactant concentration is being used for the used to find out the rate of the reaction. So it is called as pseudo first order reaction. Okay. In case of this cane sugar also you see, cane sugar is reacting with water. So 2 reactants are there, but only one of the reactant concentration, that is only sugar concentration, is taken. Water is present in excess again. So it is another example for pseudo first order reaction. Okay. Now let us see the factors affecting the rate of the reaction. So the first factor that affects the rate of the reaction is nature of the reactant. Under this nature, we have 2 things. One is physical state and the other one is physical size. Coming to the physical state, the gas will have the more rate compared to liquid compared to solid. Coming to the physical size, if the surface area is more, you see here, if the surface area is more, then the rate of the reaction is more. Okay, it has large area, so the reaction can occur so easily and very fastly. So the speed of the reaction will be more if the surface area is more. Okay. Coming to the next factor, the next factor is the concentration of the reactant. Next factor is the concentration of the reactant. So here the concentration of the reactant is directly proportional to the rate of the reaction. Okay, if the concentration is more, rate is also more. And here in the first case, you see we have only very less concentration, but in the second case we have more concentration. So if less concentration means less number of particle, so less number of collision occurs. Here more collision. So the rate of the reaction will be more. Coming to the third factor, it is pressure. It is only for gases, not for liquids and solids. Okay. Rate of the reaction increases on increasing the pressure. So the rate is again directly proportional to the pressure. Okay, if you increase the pressure, rate of the reaction will increase. You can see it in the picture here. On increasing the pressure, the collision between the molecule increases, so the reaction occurs very fast. Okay. The fourth very important factor is catalyst. Positive catalyst increases the rate, negative catalyst decreases the rate. You see here, this is the activation energy that is required for the normal reaction. Okay, for the normal reaction. But when you put a negative catalyst means it will decrease the rate. So activation energy is still higher, more, okay, for negative catalyst. If you are using positive catalyst, so this is the actual activation energy needed for the reaction. But on putting the positive catalyst, the activation energy is reduced. Activation energy is decreased. Okay, so the molecule get activated so easily and the reaction occurs so fast. So the rate of the reaction will be very, very high. Okay. Now the last factor is temperature. On increasing the temperature, rate of the reaction is also increasing because the molecules will move very fast. Okay. Whether the reaction is exothermic or endothermic, whether the system is absorbing the heat or releasing the heat, the rate of the reaction is going to be very high on increasing the temperature, directly proportional. Okay. Now coming to the next topic, which is Arrhenius equation. So we have K is equal to A into e power minus EA by RT as the Arrhenius equation for us. Okay. And where A is the Arrhenius constant and pre-exponential factor we can say, or frequency factor, and EA is the activation energy, R is the gas constant, and T is the temperature. And on increasing the K, temperature will increase. If you increase the temperature, rate constant will increase. If the temperature goes to infinity, rate constant will be equal to just the Arrhenius constant alone, that is frequency factor alone. Okay, and two more formulas we have, and these formulas are also a formula y is equal to mx. This is actually the mx and this is the c component. Okay, this is log a is c actually. Log a is the intercept, and here you can see minus ea by 2.303 r is the slope value, and y x-axis is 1 by t, y-axis is log k, and log a, this is the intercept. Log a to the base 10 is the intercept. Okay, and for two different temperature system, we have two different types of rate constants. So log k2 by k1 is equal to minus ea by 2.303 r, t2 minus t1 by t1 into t2. So these two formulas we will use for solving the numericals. So now based on all these theory part, let us try to solve the some of the previous year's questions of JEE and NEET on this topic. Okay, so let's start from the first. So question number 1 says that for a reaction 3A giving 2B, the average rate of appearance of B is given by delta concentration of B by delta T. The correct relation between the average rate of disappearance of B with average rate of disappearance of A is given in the option. So first let me write the rate of the reaction. So it is minus 1 by 3 delta A by delta T, which is equal to plus 1 by 2 delta B by delta T, right? So this is A is a reactant, B is a product. So the stoichiometric coefficient is going to the denominator with a minus in case of reactant and plus in case of product. Now, what is delta B by delta T? Take this 2 to the other side, it goes to the numerator. So minus 2 by 3 into delta A by delta T. Okay, so this is the answer. So the rate of appearance of B is given by this equation. So minus 2 by 3 del A by del T is given in option C. So option C is the correct answer for this question. Okay, just write the rate of the reaction and get the answer by cross multiplying. Okay, taking the term which we want from one side and taking the other things to the other side. Okay, coming to the next question. The correct options for the rate law that corresponds to overall first order reaction is. So we have to get the order as 1. Okay, we have to get the order as 1. So in all the cases, just try to add the powers. Here we have 0 and 2. So 0 plus 2 is 2. It is second order. Here 1 plus 1 is 2, second order. Here 1 by 2 plus 2. So it will be 5 by 2, which will be equal to 2.5. So it is 2.5th order. And here we have minus 1 by 2 plus 3 by 2. So it is 2 by 2, which is equal to 1. So this is the first order reaction. Okay. The overall order of the reaction is 1 in case of option D. So option D is the correct answer for this question. Okay. Now coming to the next question. Coming to the next question. For a certain reaction, the rate is equal to K into A power 2 B power 1. When the initial concentration of A is tripled, keeping the concentration of B constant, the initial rate would. So what we have to do? So take the rate equation. Rate is equal to K into A power 2 and B power 1. So this is equation 1. Now, increasing the concentration of A to 3. Concentration of A is tripled, right? So K into 3A, concentration of A is tripled, okay, into B. So 3 square is 9. So it is 9K, rate is equal to 9K, concentration of A power 2, B power 1. So this is nothing but the first equation. This is the second equation. So the second equation rate is 9 times. It is increased by a factor of 9. Initial rate would increase by a factor of 9. Answer is option B. Okay, such an easy question. Okay, just multiply by the thing that is given in the question and get square it and get the answer. Now moving on to the next question. Assertion reason type. The assertion says that a reaction can have zero activation energy. No, a reaction cannot have zero activation energy. So all the reaction at least needs some activation energy to get activated to form the products. Okay, it cannot have zero activation. So A is false. A is false. A is false is given only in option C. So that is the correct answer. Also cross check with the reason given also. Okay. So the minimum extra amount of energy absorbed by the reactant molecule so that their energy becomes equal to threshold value is called activation energy. Yes, that is the definition for activation energy. Minimum amount of energy required to which is being observed by the reactant molecule to get activated. So option C is the correct answer. A is false, but R is true. Okay. The next question is, for a chemical reaction 4A plus 3B giving 6C plus 9D, the rate of formation of C is given. Rate of formation of C is given. That is Rate of formation of C in the sense it is nothing but dC by dt. Okay. And the rate of appearance of A is also given. The rate of reaction and amount of B consumed in interval of 10 seconds respectively will be. So first let us find out the rate of the reaction and then we will find out the amount of B consumed in interval of 10 seconds. Okay. So let me write the rate equation first. So the rate of the reaction, rate, so I'll start from above so that I will get some space. Okay. So the rate of given reaction, it will be equal to minus 1 by 4 dA by dt, which is equal to minus 1 by 3 dB by dt, which is equal to plus 1 by 6 dC by dt, which is equal to plus 1 by 9 d into concentration of d by dt. Okay. Now, the rate of the reaction with respect to C, it is equal to plus 1 by 6 dC by dt. So it is equal to 6 into 10 power minus 2 divided by 6. So 6 gets cancelled. So the rate of the reactor is coming out to be 10 power minus 2 mole per liter per second. Okay, 10 power minus 2 mole per liter per second. So either option B or D should be the correct answer. Okay. Now next we have to find out the amount of B consumed. Amount of B consumed. Rate of the reaction with respect to B. Rate of the reaction with respect to B is equal to minus 1 by 3 dB by dt. Right. So what is dB by dt? Minus dB by dt. It is equal to 3 into the rate of the reaction. Okay. So 3 into the rate of the reaction is found out to be 10 power minus 2, right? So 3 into 10 power minus 2 is equal to minus dB by dt. Okay. So now after interval of 10 seconds, after the interval, of 10 seconds, it will be equal to 3 into 10 power minus 2 into 10. So it will be equal to 30 into 10 power minus 2 mole per liter. Okay. So the answer is coming out to be option B. Option B. So this 10 power minus 2 is the rate and 3 into 10 power minus 2 is the amount of B consumed in the interval of 10 seconds. Okay. Now moving on to the next reaction, next question. The given graph is a representation of kinetics of a reaction. The graph is given, x and y axis are given in the 4 option. We have to find out. So first is zero order, the second is first order. For zero order reaction, if I and the rate and concentration, time and concentrations are given. Okay. So on increasing the concentration of the reactant, rate is not going to get affected for zero order, right? For zero order reaction, for zero order, the rate of the reactant is independent. Rate is independent of the concentration. So the rate is equal to K into A to the power 0, right? So even if we increase the concentration, we will not, the rate is not going to get affected. So if I put y-axis as rate and x-axis as concentration, the graph will fit into that. So it should be either option C or D. Then coming to the first order, for first order reaction, the half-life is independent of the concentration. For the first order reaction, the half-life is T half is independent of the concentration. So T half is independent of the concentration. So if I take y-axis as T half and x-axis as concentration. So on increasing the concentration, the half remains same. So this graph is fitting into it. So the correct answer is option C. Correct answer is option C. Okay. Now let's move on to one more question. For a first order reaction A giving product, the initial concentration of A is 0.1 molar, which becomes 0.001 molar after 5 minutes. The rate constant for the reaction in minutes, minute inverses. So for the first order reaction, we have to find out the rate constant. So what it is? It is K. K is equal to 2.303 by T into log of the initial concentration divided by concentration of the reactant after some time T. Okay. So it is equal to 2.303 and the time is given in terms of minutes and which is 5 into log of initial concentration is 0.1 and concentration after some time T is 0.01. 0.1 0.1 is nothing but 10 power minus 1 and here it is 10 power minus 3. If I cancel out this, I'll get 10 power minus 2 and here it is log of 10 power 2. So we know that log of m to the power n is equal to n into log m. Okay. So log of 10 power 2 is equal to 2 into log 10. So log 10 is equal to 0 into 2. So what you do? Just put 2.303 divided by 5 into 2 into log 10. Log 10 is equal to 1. So the answer would be equal to 0.9212. Rate constant is 0.9212 minute inverse is the answer. Okay. The correct answer is option B. Correct answer is option B. Moving on to the next question. The slope of Arrhenius plot ln k versus 1 by t of first order reaction is minus 5 into 10 power 3 Kelvin. Okay. The value of the EA, that is activation energy of the reaction is. We have to find out the activation energy. So let's start with the Arrhenius equation. So Arrhenius equation is K is equal to A into E power minus EA by RT. So take log on both the sides. So ln K is equal to ln A plus ln E power minus EA by RT. Okay. Now here ln K is equal to ln A minus logarithmic and exponential gets cancelled. So it is minus EA by R into 1 by T I take. Because it is a formula y is equal to mx plus c. Okay. And here m is the slope and the slope is equal to minus EA by R. So what is that? Slope, it is minus 5 into 10 power 3 which is equal to minus EA by R. So minus minus is getting cancelled. So EA is equal to 5 into 10 power 3. R value is 8.314 joule per mole. So which is approximately, which is equal to 41.57 into 10 power 3 joule per mole, which is approximately equal to 41.57 kilojoule per mole. Okay, so that is the activation energy. So activation energy is this. So option B is the correct answer for this. Okay. Now let's move on to one more question. If the rate constant for a first order reaction is K, The time required for the completion of 99% of the reaction is given by. So, from the first order reaction and using rate constant relation, T is equal to 2.303 by K into log of the initial concentration divided by concentration of the reactant after some time T. Okay. Now for 99% completion of the reaction, now for this T is equal to 2.303 by K into log of initially 100. Now 99 has got reacted. So 100 minus 99. Okay. So 100 minus 99 is nothing but 100 by 1, right? So it is log of 10. We can write this as log of 10 to the power 2. So which is equal to 2 into log 10. Log 10 is equal to 1. So T is equal to 2.303 by K into 2. So it will be equal to 4.606 by K. Okay. So the answer is option A. Correct answer is option A. So coming to the next question. If compound A reacts with B following first order kinetics with rate constant 2.011 into 10 power minus 3 per second. The time taken by A in second to reduce 7 gram to 2 gram will be log 5, log 7, log 2 values are given in the question. So this is a JE question, so that's why options are not given. So we will try to find out the answer. So we'll take the rate constant relation again for this. So T is equal to 2.303 by K into log of A naught by AT, which is equal to 2.303 by K value is 2.011 into 10 to the power minus 3 into log of initially it is 7 and after some time it is 2. Okay. So what it is? 2.303 by 2.011 into 10 power minus 3 into log of 7 minus log of 2. Log of A by B is equal to log of A minus log of B, right? So we have to do like this. So it is equal to 1 into 10 power minus 3. Log 7 is 0.845 and log 2 is 0.301. So it will be equal to 622.99. So now it is approximately it is equal to 623 second. The time is approximately equal to 623 second is the nearest integer. So the correct answer is 623. Okay. Now let's go with the next question. For conversion of compound A to B, the rate constant of the reaction was found to be 4.6 into 10 to the power minus 5 liter per mole per second. The order of the reaction is. Now here you see the unit. The unit is liter mole inverse per second. So we have seen on general formula, right? Mole by liter 1 minus n and second inverse. So here if you substitute the n value as 2, you will get mole inverse, liter and second inverse. So which is nothing but liter mole inverse per second inverse, right? Okay. So this is actually the second order reaction. So order of the reaction is 2. So from the rate constant unit, we can get the order of the reaction. Okay. So it's very easy. Let's move on to the next question. For the first order reaction A giving B, the half-life is 30 minutes. Half-life is 30 minutes. So for the half-life, for the 50% conversion is 30 minutes. Okay. Now the time taken for 75% completion. So half of 50 is 25. Okay. If that has to be get reduced, then what we have to do? Time taken for 75 percentage completion of the reaction will be equal to 2 into the T half. Okay. So this is the T half value. This is the T half. Put 2 into T half. 2 T half. 2 into 30. This will give 60 minutes. For 75 percentage of the completion, we need 60 minutes. Okay. Coming to the next question. For a reaction given below is the graph for ln K versus 1 by T. The activation energy for the reaction is equal to. So again, we have to use the Arrhenius relation. So it is K is equal to A into E power minus EA by RT. So multiply by log ln K is equal to ln A minus EA by R into 1 by T. Okay. Y is equal to mx plus c. So here the slope is equal to minus EA. It is EA by R plus EA by R, and it is equal to 20. Here it is 20 and here it is 5. No, so it is 20 by 5. It will be equal to 4, and EA is equal to 4R, which is equal to 4 into R value is given as 2 calorie per Kelvin per mole. So 4 into 2, so it will be equal to 8 calorie per mole. Okay. So the activation energy for this reaction is 8 calorie per mole. Okay. Coming to the last question for this session. So for a reaction whose reactant is A and the product is B, concentration of both are given. If formation of compound B follows the first order kinetics and after 70 minutes, the concentration of A was found to be half of its initial concentration. It is half of its initial concentration. Now, then the rate constant of the reaction is x into 10 power minus 6 per second. The value of x is. So we can use half-life period. Okay, because it was found to be half of its initial concentration after 70 minutes, right? So you can use the half-life equation, half-life formula for the first order reaction. So the half-life formula for the first order reaction is K is equal to 0.693 divided by T half. So it is equal to 0.693 divided by T half is 70 minutes, and we have to find out in terms of second. So 70 into 1 minute is equal to 60 seconds. So 70 minutes is equal to 70 into 60. So it will be equal to, so in terms of 10 power minus 6, we have to find out, right? So we can put 6930 into 10 to the power minus 4 in the numerator and take 100, which is there in the denominator, to the numerator. So it will be minus 2. So finally, we will have 10 power minus 6, and 6930 divided by 7 into 6, that will give 165 into 10 to the power minus 6 per second as the answer. Okay. So this is the rate constant value, in which the value of x is 165. Value of x is 165. Okay. So very easy. So from the T half relation for the first order reaction, we are finding out the rate constant directly from the values given in the question. Okay. So I hope this session is very useful for you all. We will meet up in the next session with a new lesson. Okay. Thank you so much for listening the lecture. Thank you all. Thank you so much. Take care.